quadrilaterals, which is four-sided, and then we go polygons. Polygons is like all of them and under one umbrella. So if you go to page 11, okay, I just asked you to graph and sketch. So for example, hey, sketch me an obtuse isosceles. You can be creative on how you do that. Some of you don't want to erase. It's okay to erase and start over, right? If you draw your diagram, it's like, wait a minute, this doesn't look right. Start over, right? So obtuse, right? Obviously, you want to make sure there's at least one angle that is bigger than 90. So I pick 100. It's going to be up to you how you want to make this happen. And the isosceles, you either use numbers or use markings, right? So if two sides have the same marking, then I know this is an isosceles. Or if I have two angles that are congruent, that tells me the same story, right? If you want to say 10 centimeters, 10 centimeters, or whatever, that's fine. That works too. So you just have to be creative there. Obtuse scalene, I made sure there's an obtuse, and I made sure all sides have a different measure. I will go, or you could have had it like this if you wanted to. Let's pick like 150, let's say. And then you're like, okay, this is 5 centimeters, 15 centimeters, and 30 centimeters, right? Or something like you're making sure. I'm not gonna pick on you and like actually see if that works, because it could be that it doesn't work. When it comes to sketching, I'm not gonna pick it apart as long as it kind of matches the criteria. I would suggest do markings rather than numbers when it comes to sides. Okay. Right isosceles, it looks like this for me, but you could have had, right? Make them sort of the same. There's your right, and then you have it like this, and you just make these two sides the congruent sides. That's also a right isosceles. So you can turn it, rotate it, do whatever you want. Okay, so be creative. Just make sure you're consistent. Okay, let's go to. We're going to take this to a bit of a higher level now. We're going to bring in sine law, cosine law a bit more. Basically, everything you've learned in trig, you can bring with you in here. Everything you've learned in trigonometry, bring it with you when it comes to triangles, okay? So for example, if I ask you to classify these triangles here, and classify, it's always by side, by angle. You're going to need to do work most of the time. So for example, here, I'm going to grab highlighters. I don't know if you see it, right? But inside the triangle, there's nothing. But I don't know if you see the straight lines here, right? There's a straight line there. And I know that if this is 120, then I know that this is 60, right? It's not even, mental math is very welcome to my class, right? Like in this case, you don't need to show a whole lot of work there. Next, you look at the 150 here. You focus on that, right? If this is 150, then this is 30, yeah. Aha, so I've got two angles now inside, right? What do we call this property? I'll just say straight angle. Straight angle is always equal to 180, right? I will do the same thing here. Straight angle is equal to 180. That's what I'm using there. You got it, right? You getting it? I'm not going too fast. Anyways, so now you've got 2 out of the 3. So how about we call this angle A here? Angle A is what? 180. There's a lot of 180s in trig, so sometimes you're confused, like, wait a minute, like 2 angles 180 and then 3 angles 180? Yes. The answer is yes. So minus 60, minus 30, right? So the 2 that are here, we're subtracting, and what do you end up with? Mental math, this is 90, right? You're taking away 90 from 180. So you have a 90 left over. Doesn't look like it, does it? let's not worry about it too much. Right? I'm using software and I can't always make it perfect. But based on math right now, we determined that that is a right angle up there. So we can now say, because of this, we can start our name by saying this is a right. What else? Scalene. We don't know a single side length, right? We don't know. But because all angles are different, we know that all sides will be. What happened there? What happened there? Scalene. There. It's right scalene. Right? I make a note here because remember, you're going to study for the exam. You're going to go, what happened there? How did we determine that, right? All angles are different. Therefore, all sides are different. We know not a single side length. We don't need to know. It's okay. The problem is when you know all three sides, then you have a problem. Then you need to do some solving. Okay. Will I do this one? I think these ones are fairly simple to do. But let's just do one more. You've got, you know for sure this is a right. Right something because of that. So right something. We need to figure out this is equilateral, whatever. It's definitely not equilateral, right? Because there's a 90 out of the question. But this one here, 41 and 49, right? I don't know if your teacher's always in a right triangle, just make sure the other two add up to 90 and you're good to go. So because of all of them being different, it's also a scalene, right scalene again. And then this one, it's definitely right. Can we definitely say that it's scalene or possibly isosceles? We can't definitely say. Okay. Do some work. So we call this F, which is a leg, right? So we're going to say that F is going to be square root of 3.9 squared minus 2.8 squared. Wait a minute, can I use Pythagorean theorem? It's a right triangle, yeah, and I know 2 out of 3 sides, so yes. Okay. Why am I saying that? Why am I being so silly, right? Because I see students use Pythagorean theorem on something that's definitely not a right triangle, right? So don't fall into that habit. 7.37, and so we root that. We're rooting for it. Hey. Meters. Okay. So now, okay, guys, listen carefully. Round to 2 decimals and just go with the numbers. Oh, but Mr. Richardson is really close to that one, right? It's really close, but it's not exactly. So this is scalene, right? All three sides are different. So boom, scalene. I hope you get the hang of it. I think I'm just gonna camp here for a bit with triangles, and then we're gonna take it to the quadrilaterals. All right. The title gives this one away. Title gives this one away. So let's highlight that. Using sine law and cosine law to classify triangles. Okay. At times, there will not be enough information given to classify the triangle. Then you must use all tools you've learned about them to find out more. Okay. So I will say this in the notes here. All 3 sides are known. Therefore, we can already say what kind is it in terms of side length. Scalene, right? Got it? Okay, what else do we need to check for? Angles, right? We don't know. Does it look obtuse to you? It does, right? We're kind of suspicious on this one. But you have enough information to know more. Which one would you go for? What's the one angle you would want to check for if you only wanted to check for one? Which one? Why? Why? I'm just joking. I know. Because why? Why is the right answer? And it's the longest side across from it, right? I didn't plan that. That just worked out. So this is the longest side. So yes, this is our suspect number one here. Is it obtuse? Right? Is it obtuse? We'll check. Side, side, side. What do we need to use for that? Aha. Right. Why do I even teach? I should just hand it over to you guys and you take care of it. You graduate yourselves, okay? No ACs anymore. Cosine of y is equal to, remember, this side, I would say put that one down first, right? And then you take the other two. Some of you already did this, I know. That's okay. Right, so the other two there, and then it's 2 times 4.9 times 2.5. You figure that out. I have the key here. Anyways, if the nice thing here is I will ask you to stop after this step. So if you type in the top, okay, what are we looking for there? What would we be watching for? Anybody remember? What did we get there? You see that negative? What does that mean? The bottom, if you go 2 times that, that is 34.3. It's going to be obtuse, guys, because of this, right? This right here, we can stop here. You're allowed to stop there because you're showing me you understand, right? Indicates an obtuse angle. That indicates an obtuse angle. So it's and done. You don't need to solve. However, we'll do it anyways. We'll go cosine inverse of that. So I'll go 0.95 divided by 34.3. That is negative 0.027, and it keeps going. Shift cos. It's 91.59. You can stop here. You can stop there. As soon as you show me that negative, you can say, therefore, it's an obtuse scalene. That is what I'm after, really. And so this one would be worth more, right? Because you have to use cosine law. You have to know what it means. If this had been a positive number, what kind of angle are we expecting? The answer is an acute, right? But there will be an instance where it's going to be 0. Watch, I'm going to show you. Maybe I'll give you I'll tell you already ahead of time. If this ever turns to 0, guys, what's cosine inverse of 0? Has anybody tried it before? Then it's a 90-degree angle, exactly 90. So if it's positive, it's acute. If it's not 0, it's exactly 90. And if it's negative, you have an obtuse angle in your hands, right? So should I do that here? Hold on. Cosine inverse of a negative, it will be an obtuse. angle, which is greater than 90. Cosine inverse of 0 is a right angle. Exactly 90 degrees. Cosine inverse of a positive is an acute. And this is worth boxing in, right? So if you end up with a negative here I'm talking about this step right here where my pencil is hovering right here. That's a negative, you know it's obtuse. If this is a positive, you know it's acute. If this number turns out to be exactly 0, which will happen, I promise you that I already inserted it in some examples, and you know it's a right angle. Okay, so cosine laws, if you use it, it's going to be quite helpful. Okay, one more here. Yeah, this is worth probably doing one of these around it so that it sticks out when you flip through your notes, right? Okay, next example. Look at this one here. You're good, right? You're still with me? Some of you are falling asleep. Hold on. I'm gonna be like, wait a minute. What is this here? Can I just classify it as is? Not really. You don't have enough information to definitely say so. So you see that pair? What does that mean? If you have a pair, you use sine law, right? Sine of 49 over 380. And then it's sine of which angle can you solve for given this side? Sine of A, right? Over 500. And so you cross multiply and then divide here. So you keep sine of A like that. 500 times sine of 49 divided by 380. And then next step would be A. Angle A is sine inverse of whatever you get here. So let me go 500 times sine of 49 divided by 380. 0.993 dot 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 83.24. I'm going to underline that. Now that I have A, I can find C, right? And I'll just give you the answer. The answer is 47.76. So now I can definitely conclude that this is what? This is definitely, based on the angles, every single angle is less than 90. So I can say this is an acute, right? And since they're all different, all angles are different, scalene. Mr. Dirksen, what if I solve for all sides and then end up saying scalene? Not a problem. You go for it, right? But you don't need to. Okay, I'm going to stop here and let you fly solo here. I cannot cover every single scenario, so that's where I did spend quite a bit of time putting these together to test your knowledge, okay? So how about for today, I want you to do page 14 and 16, skip 15, okay? So I will actually say whatever you don't finish, that's your homework. 14, page 14, 15, I'm gonna do one more. because I know you're very capable. And 16. Okay. I would say this is you should definitely do this. But I will post everything from 15 all the way to let me see, all the way to 22. Key will be from page 14 all the way to 22. I'm going to post that. So if you want more, if you're interested in more, I will post all of those. And you'd be surprised how many of these show up on ACs. Not exactly, but you'll be like, oh yeah, I've seen this before. I'm ready for this.